This lecture is about software security. Key takeaways about software security are that software security is proactive rather than reactive, and it is an approach to constructing secure software. Consideration of software security should begin in the requirements phase and continue throughout the lifecycle. Software security means conducting all lifecycle activities with software security in mind. Security is built into the software instead of it being an afterthought. Analysis for security modeling is performed early in the software project. The development teams construct models that show the resources that need protection and the entities that access the resources. These models help identify and formulate security requirements. During design, security patterns are employed and security design principles are applied to ensure that the security requirements are satisfied. During coding, security patterns are used and security principles are applied to produce secure code. During testing, the tests are aimed at detecting security vulnerabilities that attackers could exploit. Designing secure systems has to be taken into consideration during the requirements phase, where the capabilities of the system to protect user data and thwart malicious attacks must be defined as security related requirements. Some security-related requirements are identification requirements, which specify the extent that the system identifies users. Authentication requirements specify the extent that the system verifies the identity of users. Immunity requirements specify the extent that the system protects itself against malicious programs. Integrity requirements specify the extent to which the system ensures that the data and communications are not corrupted. Intrusion detection requirements specify the extent that the system detects attempts to access it on by unauthorized entities. Non-repudiation requirements specify the extent that the system prevents any party from denying all or part of an interaction on the system. Privacy requirements specify the extent that the system protects the privacy of users. Secrecy requirements specify the extent that the system conceals data and communication to prevent the contents from being read by unauthorized parties. Other security requirements are security auditing requirements, survivability requirements, resilience requirements, and system maintenance security requirements. Some secure software design principles to keep in mind when developing software are: Principle 1, secure the weakest link. Identify and strengthen the weakest parts of the system until an acceptable level of risk is achieved. Principle 2, practice defense in depth. Protect the system by layers of varied defensive strategies so that the system measures are in place to prevent a full breach in case other strategies prove to be inadequate. Principle 3, fail securely. Make sure that the system is in a secure state when it fails. Principle 4, least privilege. Always limit access to systems and data at an absolute minimum. Principle 5, compartmentalize. Design the system to consist of independent, distrustful components so that if some components fail, the system will continue to operate at a reduced capacity. Principle 6, keep it simple, stupid. Highly complex software is more likely to fail and more difficult from which to detect vulnerability issues. Principle 7, promote privacy. Promote privacy for users, systems, and source code because it's valuable information. Principle 8, remember hiding secrets is hard. Secrets hidden through software are always a security risk. Principle 9, be reluctant to trust. Skepticism is better than grief when security is concerned. Don't trust, use security. Principle 10, use community resources. Use community resources that have been widely used and scrutinized.